Good morning, children. Today we are starting a new lesson of Part 2 book Parallelograms, areas of a parallelograms and triangles. Okay, so we are skipping here Heron's formula, coordinate geometry, and one more linear equation lesson. They are not for exam because this year it was reduced. So the next lesson we should go with this area of parallelograms. So first we should know what is the meaning of an area, isn't it? So it is a plane figure. Actually it is a plane. If I draw a structure here, then what the region inside is occupying certain space. So measuring that, so the magnitude of this is called as an area. Okay. So area is expressed with the numbers. Its units will be centimeter square or meter square, or it can be represented with an hectares also. They are the units of areas. We already know that the meaning of congruent triangles or figures. What are congruent figures means? What is the definition you can give? Which are having same size and shape, isn't it? And which can coincide with each other. In the same way, even the congruent figures have equal areas also. The area of congruent figures is always same. But two figures having equal areas need not be congruent. For example, a rectangle is having area length 9, breadth 6. So 9 into 6 is like this. Okay, 54. Or something else you can take. The one more square that is having a area 54 will not resemble the rectangle. They are not congruent, isn't it? Like that it will be. So if areas are same, they need not be congruent, but if the figures are congruent, then their areas will be same only. Now we will discuss the other topic, figures on the same base and between the same parallels. Here I took one figure. See, ABCD is a trapezium. Okay. And here ABGD is a trapezium, whereas DCEF is a parallelogram. Both are on the same base DC, but they are not between the same parallels. Okay. Here I am taking two triangles ABC and BCD. You can check they are on the same base BC. Now let us go with the one more figure. Okay. Here in this figure you can observe we are having two parallelograms. PQRS is one parallelogram. MNRS is the one more parallelogram. Both are on the base SR. And these, because parallelogram opposite sides are equal now. So PN will be parallel to SR. So they are between the same parallels. Okay. So the two figures are said to be on the same base and between the same parallels if they have a common base like here, and the vertex is on the vertex opposite to the common base of each figure. See, on the same line the vertices are lying. Okay, then only we can say that they are on the same base and between the same parallels. So related to this we are having an exercise. Let us go with that exercise 11.1. In that they have given few figures. You have to say whether they are on the same base and between the same parallels. If they are, you have to mention the base and the parallel lines. If they are not, you have to leave. So here the first figure, you can observe ABCD is a trapezium and PDC is in a triangle. Okay, both are on the same base CD and they are between the parallels CD and AB. Okay, so this is the figure. So the parallel sides are AB is parallel to CD. The common base is CD. Now let us take one more figure. Here PQRS is a parallelogram. MNRS is a trapezium. You can observe they are on the same base but not on these vertices are not lying on this. That's why we can't take that on between the same parallels. Okay. Next we will move to the one more figure. Here Parallelogram is there and triangle is there. So PQRS is a parallelogram and both are having this side you can take as a base, QR you can take as a base. QR is the common base and QR is parallel to PS. Okay, base is QR, parallel lines are PS and QR. So one of the very important theorem which is required for your future also, that is parallelograms, area of a parallelograms theorem. What is the statement of this theorem means, parallelograms on the same base and between the same parallels are equal in area. It says that if any two parallelograms are on the same base and between the same parallels, then the areas of those parallelograms will be equal. This is the thing we have to prove in this theorem. Okay. So theorem should be solved with the 3 steps. Data to prove, sometime construction part will be there, and proof part. In a proof part, whatever the statement you are giving, for that you have to give the reasons. Okay. These are the steps you have to follow whenever you are solving in a theorem. So data, what is the data? Here we are having 2 parallelograms, which are that ABCD and EFCD are the 2 parallelograms. They are on the same base DC and between the same parallels AF and DC. That is the given part. Now what we have to prove? Area of ABCD, this one, should be equal to this part, area of DC FE. Okay, that is the thing we had to prove. So in proof part, let us go with these triangles ADE and BCF we will take. So we know that it is a parallelogram and it is a transversal. Okay, that time this will be the corresponding angles. That is the first thing I wrote. DAE is equal to CBF. So corresponding angles, because AD is parallel to BC and AF is the transversal. In the same way, AED will be equal to BFC, this angle. There also, ED is parallel to FC and AF is the transversal. Call it as a 2. So when 2 angles are equal, the third angle is also equal from angle sum property. Call it as a 3. That is, ADE will be equal to BCF. So all the angles are equal means even. Common base you will be having AD is equal to BC, opposite sides of a parallelogram. So 2 angles and 1 side we got. That's why this triangle is congruent to this triangle from ASA rule. If they are congruent, we already said the areas will be equal for a congruent triangle. So the area of ADE will be equal to area of BCF. Isn't it? Now we will take area of ABCD as an area of ADE plus area of DCBE. Okay. So now instead of AED, if we substitute BCF, what you will be getting? So BCF plus ECDB, the same. You will be getting the parallelogram EFCD. So we got the proof there by that. Okay, first area of ADE plus area of ADCB we wrote. Instead of ADE, BCF we have written. The sum of those will be area of EFCD. So this side LHS part ABCD you are having. That's why both are having equal areas. Okay. So the converse. What the converse says means parallelograms on the same base and having equal areas. Then they lie between the same parallels. Now the one more thing you should know in this lesson is area of a parallelogram. You already know that a parallelogram is rectangle is a special type of parallelogram. So length into breadth you are getting. No? In the same way here side into attitude you are getting. Okay. So related to this theorem we will solve few problems, children. In that the first one is, in the figure ABCD is a parallelogram. AE is perpendicular to DC and CF is perpendicular to AD. They have given the measures. AB measure they have given 16. AE measure 8 cm they have given. CF measure they have given as a 10 centimeter. Now we have to find AD. Okay. First, we will find ABCD area taking this base and this as a altitude. AB into AE. So, AB is 16, AE is 8. 16 8 is 128 we are getting. Now, again ABCD area only, but base I am taking as a AD and height CF I am taking. Area is 128, AD we are not knowing, CF is 10. Transfer 10 to this side, 128 by 10, that is nothing but a 12.8 centimeter. The measure of AD is 12.8 centimeter. Now we will move to the next problem of the exercise. So the next problem is, in the figure, P is a point in the interior of a parallelogram ABCD. Show that area of APB plus area of BCD is equal to half of the area of ABCD. This is the first part. Second part is area of APD plus area of PBC is equal to area of APB plus PCD. Okay. 4 triangles what we are getting, the sum will be equal to this. That is the thing we have to prove. Okay. Hint also they have given, through P draw a line parallel to AB they are saying. So let us consider that line as a EF. Now just check it out. EFCD and triangle PCD are on the same base CD, and between the parallels EF and CD. That's why we can write that area of a triangle is half of the area of a parallelogram which are lying on the same base and between the same parallels. That's why area of triangle PCD will be equal to half of the parallelogram EFCD. In the same way, apply this side. APB and AEFD are having the same base AB, and between the same parallels AB and EF. Okay, that's why area of APB will be equal to half of ABFE. Call it as a 2. Now add 1 and 2. So area of triangle PCD plus area of triangle APB will be half of parallelogram EFCD plus half of parallelogram ABEF. So half is the common thing here. Remove half. That time EFCD plus ABEF, totally it is nothing but a ABCD. So we got the first proof. Call it as a 3. Now draw one more line passing through P which is parallel to AD, LM line. Draw LM parallel to AD. That time we got this triangle APD and one parallelogram ALMD. Okay, so this APD will be what? Half of this parallelogram. That is the thing I have taken as a 4. This side if you take, triangle CPB is half of the parallelogram MLBC. Okay, call it as a 6, 5. Now add these two, 4 and 5 you add. Area of APD plus area of CPB is equal to half of the parallelogram ALMD plus half of the parallelogram LBME. Here also half is the common thing. ALMD plus LBCM. ALMD plus LBCM. This is nothing but a ABCD only. This is called, this as a 6. Compare 3 and 6. RHS parts are same. So LHS will be same. What is the LHS part here? Area of PCD plus area of APB is equal to, here area of APD plus area of CBP or PBC, both are same. We got the proof. Okay. So the last problem of the exercise here we will move with. In a figure, PQRS and ABRS are the parallelograms and X is any point on the side BR, X is any point. Show that area of PQRS is equal to area of ABRS. Parallelograms are equal, you have to prove. And triangle, area of AXS is equal to half of PQRS. That is the thing we have to prove. First, you know that PQRS and ABRS are on the same base SR. And these are the parallel lines. PB and SR are the parallel lines. So areas, parallelograms on the same base and between the same parallels are equal. That's why area of PQRS is equal to area of ABRS. First proof finished. So from the second proof, you can observe that it is a parallelogram. In this parallelogram, on the base of AS, we are having a triangle, okay, between the parallels AS and BR. That's why you can write that area of AXS is half of ABRS, okay, but ABRS is equal to what? PQRS. So instead of ABRS, if you substitute PQRS, we will be getting our second proof, okay. So the remaining problems we will discuss in the next class. Thank you, children.